In this section, we're going to edit a light meter so that it is appropriate for use in LEED 8.1 certification. Continue from the previous lesson or open the file Office Suite Analysis 02.max. The file currently contains one light meter that's sitting 2 inches above the floor in the office. Make sure the Light Meter Helper 01 object is selected. Click on the Modify panel. In the Parameters Rollout Dimensions area, set the length to 10 feet 0 inches and press Enter. Set the width to 11 feet 0 inches and press Enter. Set the number of length segments to 5 and the number of width segments to 5. Look at the light meter helper in the camera viewport. Each of the arrows that points down indicate the orientation of the light meter and a sample point. With the number of segments set to 5 and 5, there are 25 points at which we will sample the lighting in the scene from above this light meter. If we need to measure other surfaces, we can place the light meter on the wall or we can put one on the ceiling. What is important is the orientation of the light meter, which is indicated by the arrows. The light meter will be sampling from that direction. Let's look at some of the options in the display rollout. We can show or hide the orientation of the light meter by selecting or deselecting Show Orientation. The Show Pseudo-Color option will show us the colors associated with the analysis value once we calculate the light meter. To see the value on the helper, keep the Show Viewport Text option checked. In the Values to Display area, we want to make sure the light meter is set to daylight factor. The reason why daylight factor is important is that it is the measurement used in LEED 8.1 to determine if the lighting level in the room meets the requirement for the certification. In order to meet the certification level, there must be at least 2% of the daylight in 75% of the room. In the Lighting Analysis Assistant, click Calculate All Light Meters. Once the light meter is calculated, we can see that the lowest value that's visible to us is 0.03%, and our highest is roughly 11 or 12. You can read the values a bit easier in the top viewport, but we're just going to estimate that the value is around 11. Notice that the viewport color of the light meter is all blue. To see a better range of colors, click Edit in the Modify panel Display Rollout. This opens the Lighting Analysis Assistant to the General panel. Here we need to edit the analysis value color coding parameters to get a more acceptable color scale on the light meter. The minimum value we'll keep at 0. However, for the maximum value, and this is something very important to remember, the daylight factor is a percentage. Percentages with mental ray go from 0 to 1. To set the value to a percentage, in this case 11%, enter 0.11 into the maximum value and press Enter. The scale now represents a better visual scale of the brightest areas in the scene to the darkest. We have an area of white here, which means that we're clipping the color at this value. To fix this, change the maximum value to 0.12. There is now a color gradient on the light meter helper in the viewport that shows the brightest sample points in red and the darkest in blue. If we look at the values, the light meter is showing us we need to make some adjustments in our scene to provide more daylight to the back of the room. One reason for this has to do with our current final gather values. We'll fix this later and you will see the results of the change. Close the Lighting Analysis Assistant. You can see in the top view, after we've closed that our color light meter is visible in the wireframe top view as well. Go ahead and save this file.